hopefully, if you guys are interested, you will all stay for his really cool USACO Silver coding class. So thanks so much to everyone for coming, and I will see you guys later.
Okay, thanks, Rich. Hey guys, hope you're doing well. This is lesson 3, and let me share my screen. Okay, I guess I'll just kick Rich out. All right. So just a heads up, this time we actually don't have a handout yet. A number of reasons. First, mostly because I was very busy. But the good thing about this lesson is that all these topics, like I'll be going through on a clip, so you don't really need a handout to go along with. That said, I will get the handout done as soon as possible, probably by tonight. Okay, so this time we're going to talk about advanced data structures. So that sounds pretty interesting. Let's do a quick recap of week 2 first, though. And of course, the handout is on the Google Classroom as well as the website if you ever want to check it. So last time we talked about something called dynamic programming, which covers a lot of different types of problems. The main idea is splitting up one problem into a bunch of sub-problems in order to solve it easier. Sorry, I can't speak. So of course, there's a lot of different problems that you could encounter. So the way to use DP really varies based on what problem you're given. Last time we saw finding a Fibonacci number. And we found that using an array to store the Fibonacci numbers made this process a lot easier than having to keep track of 2 variables that we constantly update, for example. So this shows up very frequently in USACO Silver, Gold, and Platinum. I would say in USACO Silver, you'll actually see 0.5 or 1 on average DP questions. Gold, there's usually 1 DP question every time. So if you can get DP down, then you're really in good shape. And it's a lot easier said than done, because getting DP down means knowing a bunch of different situations where it could occur. We also talked about paths through a grid, through an m by n grid. How many ways are there to go from one corner to the other corner? But of course, there was also a mathematical argument which made DP look kind of silly. So we changed the problem to have obstacles or hay bales on the grid. And in that case, we did actually have to use dynamic programming to solve the problem. Yeah, let me share the link. Okay, let me know if you can see it. So this time we're going to be starting off with a talk about data structures. Now it's a kind of, I remember when I first heard the word, I really didn't know what to think of it. I was like, do I have to make these data structures, or what exactly is it? Well, a data structure is just something that stores data. So it's a collection of numbers possibly, or a collection of strings. And within these data structures, they're structured so that there's some sort of relationship between the data. Now, I'm sure you guys have all seen the array. Or if this is your first class, I guess not, but you've probably seen the array. And the array is the data structure that you'll use the most in USACO because it's just so versatile. There's so many applications. We could use it for prefix sums. We could use it for binary search, for dynamic programming. So really, this is the first class that we're looking at data structures past arrays. And we saw there's a couple ways to implement or initialize an array. We could give it a name and a size, or we could actually just give it a name and the elements inside of it. And the thing about arrays is they're linear, right? They're stored sequentially. They're basically lists of elements. And we'll see that a lot of the data structures that we have to use in USACO aren't like that. So I was actually going to make a a chart, but then I found it on Google, so I just put it here. The credits below. So there's really two main types of data structures. One is linear and one is nonlinear. And as I mentioned before, arrays are a type of linear data structures. Again, because there is a clear pattern between the elements. You have to go from one element to the next. You just move you just move along the list. Today we'll be going over arrays, linked lists, stacks, and queues, all of which are linear. And then out of the nonlinear ones, nonlinear doesn't necessarily mean that it's like multi-dimensional. It just means that there's really not like a clear-cut pattern between the elements. And we'll be looking at sets and tables for today. Oh, and a bit of trees. Graphs. Now, graphs are a collection of vertices and edges. So you can have like self loops, you can have multiple edges. These things are actually very complicated. I think the idea is pretty cool, but actually not complicated. A better word to say to describe it is there's so much to talk about for graphs, especially in USACO that they have a bunch of graph questions. So we're actually going to spend the entirety of next class talking about graphs, even though it's just one out of the 8 data structures that are on here. I saw a question in the Q&A. Is line sweep a hard topic? I've heard that you use it in Silver. Yeah, it is a very hard topic. I was lucky enough to not have to use it in contest. And we won't actually be going over it because I think graphs and these topics are like show up a bit more than line sweep. But it's definitely something that you could learn if you want to. Okay, so to start, linear data structures. Part 1, we're going to talk about these 3. I added some the array list, but technically ArrayList was not in this chart. So it's actually a type of array, which we'll get to. Arrays have a couple of characteristics. First, they're fixed in length. So sometimes this is actually kind of annoying, which is why we use the linked list. So this is fixed in length. And as you saw from before, we had to either, when we're first declaring it, we have to give it a size, or we have to give it like the number or the elements themselves, which gives it a length, because we're giving the elements, which clearly there's a number of elements that we're giving it. The thing about arrays is that these elements, like if you think about the hard drive and like these variables being stored, all these elements are stored in consecutive memory addresses. And so let me draw this out actually. If we think of like these as blocks of memory, then when I try accessing an array, I would get the first element. Sorry, the position, the memory address of index 0. And the way to actually access index I is you go I steps to the right of index 0. So like to access index 4, I could either go like that, which takes a lot of time if you have a lot of elements, or I could go super fast, just add 4 times something to whatever the memory address of the array pointer is, and I get straight to the index 4 element. So what this means is that accessing elements in arrays is super fast. All right. Now let me just pull up Eclipse. Let me make a new class. And here I'll just put a lot of just testing stuff. It's going to be a lot of testing. Okay, test. Great, it has the main. When I write this, this means array, and this means the element or the data type that I'm storing inside this array. I think Rich talked about it once, but the primitive array types include ints, characters, floats, doubles, bits, some others, like longs. So these are called primitives, but you can also store it in arrays objects. Now, objects include strings, which Java already has a class for. Strings are like arrays of characters. So if you have an array of strings, you'd actually have an array of arrays of characters, which is kind of like a 2D array, but it's better not to think about it that way. In other cases, you have custom classes that you create yourself. So for example, let me go back to Eclipse. And I'm going to create a class inside test. I'll call it static. Static so that I can actually use it inside this main. Static class, and I'll call it student. Okay. And classes have attributes, or classes are made up of attributes and variables. So each student has a name, and each student has, all right, let's just say age. In the handout I use something called ID, but we'll just say age. I'm gonna write a method here. It's called the constructor. It may not make sense, but I'll explain what it means in a bit. Okay. So what the constructor does is this gives you a way to create a student object. So if I go into my main and try to create a student, I would say student s equals, and now I have to make the new object. So I say new because it's a new object, new students. And this is actually what I want to fill in. So this is what this thing called the constructor is used for. And I see that in the constructor, I'm forced to give it a name and an age. So I'll give it a name of Bob and an age of 2. Okay, so that's what the constructor is used for. And now we have our custom class called students. So I can actually make an array of students. I'll call it students. And let's just say there's 4. All right. I actually forgot to ask, but are there any questions so far? All right, that's cool too. At any time you can just interrupt by like putting something in the chat or in the Q&A. Okay, and this distinction is actually kind of important because one of the main methods that we have to use for arrays is the sort method. And if we're doing custom classes, if we're sorting an array of a custom class, we actually have to do something to the class in order to be able to sort it. In other cases, we really don't have to do anything. Okay, so the main things for an array, and I'm sure you guys probably know this already, accessing an element, you just do the square brackets and then the index. The length, remember, to get the length of the array, you don't want to put the parentheses. It's just this by itself. And then the main thing that we'll really dive deep into is arrays.sort array, R. By itself, this sorts R in ascending order. And to do this, you actually have to import a statement, which we haven't seen in a while. Normally, when we use arrays, like for all of this, we actually didn't have to import a statement. Now we have to go into java.util, which is where almost all of these data structures are stored. And we just type arrays. So I'll get rid of this example for now, or I'll actually comment it out. if I have an integer array, I'll give it some values like 5, 3, 4, 2, 1. And I want this to be in ascending order. So this is easy enough. I do arrays.sort r. And I'm just going to write a for loop that checks if I'm right, because we'll use this for loop eventually anyways. Might as well write it now. If you haven't seen this before, this is called a for each loop. I'll use a different letter. So if I do, the way to read this is for each integer a inside of r. So notice that I'm actually looping through the elements themselves, the values themselves, instead of their index positions. How do you do descending order? One way to do it, which is actually not as slow as you might think, is to negate everything in the array, to negate everything and then sort it and then unnegate it. That is usually what I do. In other cases, you can like actually avoid it, just do arrays.sort, and then in the question, you kind of like reverse the way that you traverse through the array. I'm pretty sure there's another way to use the arrays.sort method and give it like another parameter, which lets you do descending order. But I personally don't use that. And we'll talk about like if you try doing sorting in descending order for a custom class array, there's a way to do that. That you have to write a line of code anyways, and you can choose whether it's ascending or descending. Okay, so moving on. This prints out every element in A. So I just run this. Originally, this was the order, and now once I sorted it, it's now in ascending order, so it's 1, 2, 3, 4, 5. Okay. So this is just a primitive array. If we have a custom class array, again, we have students. These are the two things that you have to do in order for it to work. So you have to add the line implements comparable, and this is the name of the class that you're making. So implements comparable, less than sign, student, and then greater than sign. And we add this over here. I just want to show you what happens if you don't do this. So I'll get rid of this part, uncomment that. And I'm going to just fill in this students array with 4 students. If you're wondering how to do this, you just access the 0th element and then create a new object inside that position. And I'll do alphabetical order like that. Okay. I made these ages different so that once we sort the array, oh, I didn't mention this. We're going to be sorting the array not based on name, but we're going to sort it based on age. For some reason, I don't know if the school needs it like that. Okay, if I try doing arrays.sort students, this is the message that pops up. So it says, I can't cast student to something called comparable. And that's why we have to implement comparable. This sounds kind of weird. Like all these terms, implement, comparable, like they don't really make sense. So I really didn't understand it until like maybe a year ago, but I kept using, like I was able to use this method or use this like process without actually understanding it. So as long as you just understand, or as long as you know the lines of code that work, that's okay for now. I'm not saying like don't ever learn it, but if this like if understanding it gets in the way of like you doing the problems, then it's better to just like ignore the fact that you don't know how it works, I guess. All right. Oh, oops, implements. Okay, so we're given an error message which says, in order to inherit this comparable, we have to make a method called compare to. So that was the second step, which is create a method in this class called compare to. This is what the arrays.sort method uses to like compare two students. So like when you're sorting an array, you look at the first two or something and you compare those two. If the right one is greater, then leave it alone. If the left one is greater, then like swap their places. So the comparing method that they use is called compare to. And compared to, this would be like the student that I'm comparing this student to. So this is like the other student. And for ascending order, all I'm going to do is return this dot age minus the other person's age. Yeah, compared to would return an int. So you would want to return an int. That's actually a great question. Suppose you had like, maybe I had a Boolean, like is cool, right? And then if someone is cool, then they're going to be, I don't know, on the right. So instead of doing compare to, you could actually do like, if, let's say if I'm cool and student is cool, then look at something else. Like then look at the next thing you want to compare, which is age. So return this dot age minus s dot age. Otherwise, if one of us is cool and the other is not, then put the other one to the right or something. Yeah, but for this case, we don't have this Boolean. So we just return this dot age minus s dot age. And this, I'll comment it, is ascending order. If I wanted to do descending order, I could just switch s dot age and this dot age. That'd be descending. And I think you got a great question, because what if two people have the same age? Well, then what I want to do is, let me cut that. So if they have the same age, if this dot age equals s dot age, sorry, not single equals, double equals. So if they're equal, then I want to look at something else to compare them by. So I might just say, if I had another attribute, I would put like compare those. And then outside of the if statement, since they're, if I pass this, if this wasn't true, that means they're not equal, which means I could just do that. I don't know if that makes sense, especially since I left this part open. This would be the way to like use or to sort based on two things instead of just one thing. Okay, so get rid of this. Finally, we can go back here, sort students. And I'm just going to print stuff out to make sure I did it right. So for student S and students, print out the name, add a space between that and the age. Okay, save it and then run. Awesome. This is exactly what we wanted because we wanted to sort by age, and the names aren't particularly sorted. Okay. So are there any questions about how to make a class sortable? Awesome. All right, let's go back. That was a long time on array. Oh, how do you do multiple sorting? Yeah, I'll go back to that. It would involve a bit of like if statements. It's like if I'm unable to compare based on age, and the only way I'm unable to compare based, yeah, sure, I'll make a grade. For the sake of time, I'm not going to add like grade to the constructor and all that. But like, let's say if I can't compare based on age because they're the same, then I want to compare based on grade, which I feel like would be kind of be the same, but that's okay. So I just return this dot grade minus s dot grade. Again, this would mean that I'm putting my grades in ascending order. Oh, grade, I guess like the number grade, like homework grades or whatever. Yeah, I don't know. I don't know what you meant, but that's a good integer. So in short, what this does is this is like sorting by age first, then sorting by grade. Okay. Did that answer your question? Cool. Okay. Now we move on to ArrayList, which, as I said earlier, is actually just array. And if you go into the ArrayList class that Java wrote, it's an array that changes its size if you add too many elements. So if we start off with like an array list of size 10, or we start off with an array list of size 0, but inside it's stored as like an array list of size 10. Once we add too many elements to the array list, once we add our 11th element, then the array doubles in size, and it gives us extra room to add. So instead of adding one memory location each time we add an element, it's doubling in size, just so that we have to double less times, or we have to change the array size less times. On our end, it looks like it has modifiable length because we can add and remove elements freely. This implements the list interface, which means you can just think of it as it is a type of list. And since it's a type of list, it has to have these three methods: .size, .add, .remove. There's some other ones, but this is what's really important. Like arrays, the data type can be primitive or custom. There's a bunch of methods. Typically, I actually don't think ArrayList is, or some of these methods aren't used much. Let's say the name of my ArrayList is AL. So AL.size gives the size of it. Get is like accessing an element. Add by itself, if I have just one number in here, that means I'm adding to the end of the array list. If I want to add somewhere in between, I would have to specify the index first and then the element that I'm trying to add. I want to go to the whiteboard here and show you what it looks like when I'm adding an element to an array list. In an array, all these elements are stored consecutively. And let's say when I first start off, I just have one element or 0 elements, and then I add one element to my array list. Let's say I add another I'll actually do numbers for this. So I add 5 here, then I add 7, 4. And this would look like AL dot add 5, then dot add 7, dot add 4. There's no extra parameter here because I'm adding to the end. And let's say I do this a bunch. And my last few elements are like 3, 4. Now all of these operations took O of 1 time. O of 1 means I can do it basically instantaneously. It doesn't matter how big my data is, how big my array is. As long as I'm adding at the end of it, I can just go to the first index location, add the size, and I reach whatever is at the end. So that's the neat thing about arrays being stored in consecutive memory addresses. However, if I try adding an element to the middle of the array list, like let's say right here, if I want to add an element here, sure, I kick out this one. So if this was a 5, now I'm replacing it with a 3. Now the 5 has nowhere to go. It has to go here. So I keep kicking out, and I'm essentially pushing this whole right side of the array to the right, which takes a lot of time if your array is a huge array. So that's one downside to ArrayList. And we'll see a data structure, LinkedList, which does adding elements very quickly. Okay. Removes the index position, the element at position I. Same as this one. It's going to take a while to like shift everything back to the left if I remove something from the middle of the list. Collections.sort AL is the way to sort an array list. It's very, very similar to arrays.sort. The only difference is I have to import java.util.collections at the top of my Java file. That's actually the only difference. Maybe like the parameters that this takes might be a bit different. The same as before, if you have a custom class, you would again have to use these things, implement comparable, and then create the method called compared to. Okay, LinkedList is the alternative to arrays and ArrayList. This also has modifiable size. The difference is elements are not in consecutive memory addresses. Whereas before, these are all, we can think of this as memory. LinkedList maybe has something here, then it has something here, then here, then here, here. So it's really weird. And I'll label these 0, 1, 2, 3, 4 for the order of the for the order that they appear in the linked list. A linked list is actually several nodes linked together. And these nodes are classes that Java has already defined. And again, for all of these data structures, you don't have to make anything. Java has them all created for you. I guess except for like graphs and trees, you have to kind of make it yourself. But the rest of them, like linked list, array list, stat queue, map, set, all of these, they already made for you. This also has lists. So there's these three. I'm going to go through this a bit quicker. Now, to think about what linked list looks like, this is a visualization of it. Here are my elements in the linked list, 5, 4, 7, 9. And there's a clear order to this. Like 5 would go to 4, 4 would go to 7, 7 would go to 9. So that's why it's still a linear data structure. However, it's not necessarily the case that this element is right after the previous element. So a node or one part of the linked list has a value, which is kind of like the value for an array. But it also has a pointer to the next element in the linked list. And this way, I guess you can imagine, like if I start at index 0 then I can go to index 1, or it wouldn't be really indices, they would be like element 0, then element 1. I can keep going. And in most linked lists, they circle back to the start. Sometimes linked lists even have like a previous pointer. But this is kind of like the simplest linked list that you can come up with. So let me clear this and draw that really quickly. Now, if we imagine trying to add an element into this linked list, it's actually pretty quick because I don't have to shift everything. If I wanted to, let's say, add this element in right here, then I can just change my pointer from that to that. Then I set this pointer to go from here to here. And I would be deleting this pointer. So this adding operation is very quick because I just had to update 2 pointers, add 2 pointers, and remove a pointer. Or to be more precise, it would be updating a pointer and then adding a pointer. So it's very quick adding. The problem is, since they're not in in consecutive memory addresses, I can't go directly from index 0 or element 0 to element, let's say, n, using the same method that I did for arrays. I can't just add like a multiple of n to the memory address. So I would have to go through each element. I would have to iterate through them until I reach element n. So that's the downside of linked lists. Are there any questions so far about ArrayList, linked lists, how they work? Oh, sorry, there's a question in the Q&A. Does Java have structs like C++? That's a good question. I think there's interface and class, which may do the same things. I actually I'm not too familiar with C++. I really used it for USACO only. And that gives you an idea of like how little USACO goes into programming languages. So I'm actually not sure. That's a good question. And I would leave it up to Google for that. I wish I could answer it. Okay, linked list again has size, add, remove. It has get, which again is a bit slower, but then add and remove are very fast. The other 2 methods are pop and pull, which basically do the same thing. And really, you don't really have to worry about like the edge case where they act differently. And that's when the linked list is empty. I'm actually going to go back here. Let's make a new class. The naming of my classes are horrible, so don't take this as a good example. And since I'm lazy, I'm going to go to the top and say import java.util.star. So I don't have to keep writing these import statements. The way to implement, or the way to initialize an array list of type integer would be this, using these angle brackets, which are always a sign of like what data type you're working with inside of, like the thing inside of them is what data type you're working with. And this is like the basic format that all of these things follow. If I wanted to make a linked list of integers, really all I would have to do is just change the word array list to linked list. So if I added a couple elements to linked list, 3 would be added to the last element, but there's no element, so it'd be the only element in the list. That adds it to the end, which is after 3. And let's say I want to add something to index position 1, and I'll add 5. So this would, if I printed everything out in LinkedList, it would look like that, because I added 3, then I added 4, but then I added 5 between 3 and 4 because it's at index position 1. At this point, if I do LinkedList.pull, what this does is it takes the first element. I actually do system.out.println. This takes the first element, removes it, and then returns it. So instead of this like printing nothing, this would actually return a value of 3 because that's what I removed. So if I print that out, I should get 3. And now my linked list is just 5 and 4. Linked list, we'll get back to it in a bit because we're about to talk about queues. Now queues are more of a very common thing you'll see throughout all programming languages. Most programming languages have like an implementation of queue. So it retains the order in which elements were put into the queue. Here's a good image I found. Again, I didn't create this, I found it online. The term for putting an element into a queue is enqueue, and taking it out is dequeue. And you can think of this as like a lunch line. As students go into a lunch line, the first person to go in gets served first, and then the second person. And each time they get served, they like get dequeued. Every time someone goes into the line, they get enqueued. So as a lunch line, or you could think of it as an application of the queue is a Spotify queue. Like you add songs to your queue and they play in the order that you added them. Something we'll see next time is breadth first search, or BFS, which uses a queue specifically. I'll get to that. So the terminology for this is first in, first out, because the first thing to go in always goes out first. And that's called FIFO. In Java, there's not actually a queue class. It is an interface, or it's either an interface or an abstract class, which means I can't use it directly. But linked list either inherits, or let me actually search that up. So queue Java. Okay, so it's an interface. I just wanted to be precise. So queue is an interface, and linked list implements queue as an interface. So it acts like a queue. And linked list is the thing we just talked about. So if we ever want to use a queue inside Java, we just use the linked list. And what would that look like? Well, I'll still keep the name LL. But adding something to the beginning would be, or it would actually kind of be reversed. It's a bit tricky because most of the time, because pull takes the element from the beginning of the linked list, and then I would be adding to the end. So it's a bit different from what the image shows. What I would actually write in code would be the opposite of this, because I would be pulling the 0 element, and I would be adding at the end. And in code that would look like ll.add 1. That would be enqueuing something, then ll.pull. This takes in no parameters. That would be dequeuing something. Okay. Any questions about queues? So besides like this first in, first out feature, queues are pretty boring. That's all they do. All you use them for is add stuff to them and take them out. I guess you can also like get the size of it. But all these things are methods of linked list. So this is a good page to memorize. Yeah. All right. Now the opposite of queue is a stack. So whatever comes in first in a stack, or sorry, whatever comes in last in a stack gets treated first. And we can think of this as a pile of dinner plates. Like, I don't know, your parents are there washing, and then you keep eating. So you put a plate on the top, and then every time they take a plate off. But then, okay, well, so they clean that plate, but then you put another one on, another two on, and they have to take it in the order that they were that they're in right now, from the top. And now you put a lot more plates on because you're hungry, and then they have to take it off in that order. Another example of a stack is actually something I just showed, which is the undo and redo functions. Notice that when I draw stuff like that, when I draw things, this is like putting something inside of a stack. And the terminology for that, I didn't write on the slide, but it's called pushing something onto the stack, which is like pushing it onto the top of the stack. I would be pushing stuff, plates onto it. If I'm looking at the undo redo analogy, drawing stuff is my version of pushing stuff onto the stack. Popping stuff from the stack, which is the equivalent of like a queue pull, is taking stuff off, which is my undo button. So notice that every time I make a pile of plates, maybe I undo once, I undo twice, it acts like a stack. And all I'm doing is either adding or undoing it. So I'm either pushing or popping it. Terminology for this is LIFO, for last in, first out. And the methods are .size, .add, and .pop. Add and pop are the main ones you're going to use. Add is pushing, popping is popping. And it's very similar to the other ones. I just say stack full of integers. Actually, let's say strings, because we've only used integers, which is kind of annoying. All of these data structures work for things besides integers. I just want to make that clear. I'm sure you knew that. So if I have a stack of strings, I can add that, and then I can add other stuff. Like before for the queue, pop returns a value. So it not only removes it, but it also returns it. So if I wanted to like system.out.println pop or st.pop, this would print out that thing. So let me run that. I will need to. I did pull twice over there, so that's why it was a null. Okay, so I added this first, and then I added that. So this was on the top. This came in last. That's why it came out when I did pop. Yeah, this is just another explanation of that. Okay, hopefully we have enough time. Nonlinear data structures are things that, again, don't have really an order to them. And we'll look at three of them. Heap is a specific type of tree. And if I go back to slide 6, tree was a bigger category. I'm just going to look at heaps because I think heaps are really the only ones that you need to know for USACO. You don't really need to have other types of trees. sets and maps are pretty similar, and we'll get to them. So heap, usually for Java at least, it's stored as a binary tree. A binary tree is something where you have a parent node or a root node, and the children are the things below it. And in the case of a heap, each of its children, each of the children of a parent node are bigger than the parent node. And I will mention that this is called a min heap if these children are bigger than the parent node. It would be called a max heap if, for example, if it was like 100, then 90, then 70, like that. That would be a max heap. The one in the photo here is a min heap. In Java, we have a heap called priority queue. This is a bit misleading because it's called queue, but the reason it's called queue is because we have the same methods of pushing and not enqueuing and dequeuing. The problem is it doesn't follow first in, first out. So when you see the term priority queue, I would say don't think of queue, but think of a heap. Or in fact, think of it as its own thing. And what priority queue does is whenever you put something in, it gets sorted into this tree. You don't have to know about it. You just have to know the code to put something into the priority queue. And whenever you take something out, it returns the minimum element in your priority queue, which is absolutely amazing for some graph problems, which we'll see next time. Okay, so to do it, I just write priority queue. I'll do integer once again. Okay, and I could add multiple elements. I'll add 45, 30, 100, -1. And let's do this just for the sake of it. Oh yeah, here are the methods, add and pull. There's another one called not empty, or you could do the size one. So I'm going to print out all the elements of in the priority queue in order. So while PQ is not empty, not PQ dot is empty, system.out.println, whatever is the least element. So if I run that, I added all of these in, but when I took them out, it gave me the order of, it gave me the smallest ones first. So it's obviously in ascending order. All right, we have time. Any questions about priority queue and heap? Cool. Or if you do, feel free to type it. A set is a collection of unique elements. In Java, you can't do something like set integer. That just doesn't. Wow, it does work. Oh my gosh. Oops. But there's two types of sets that you want to worry about. There's the hash set and the tree set. The main difference is hash sets are not ordered and tree sets are ordered, which means that if I try going through a set, like iterating, printing everything out, and I want to do this in order, then I will use a tree set. Otherwise, hash sets are faster than tree sets. Like, so if you don't want to worry about sorting all the elements in the set, then don't use a tree set. The property of sets is if I have a set like this, and I could actually type this out in Eclipse, and if I tried adding 4 to it, and I check the size of the new set, it would still be 5. It wouldn't add it to it, and it would actually, I think, return false because 4 is already in the set. The methods that you need to know are the size of it, how to add an element to it, how to remove an element, and then whether or not the set contains some value. Okay, and our final thing is a map. It's very similar to a set in that you don't have duplicate key values, keys. You don't have duplicate keys. And you can think of a map as a dictionary where you have something on the left side and then something on the right side, and then something on the left maps to the thing on the right. Each key has a specific value, and each value has a specific key. So it's like a dictionary. These are called key value pairs, and you can iterate through it by searching up how to iterate through map Java. And there's a nice for each loop that you can use. So there's also two types here. Again, based on whether or not you want it to be ordered or not ordered, you use, sorry, not ordered or ordered, you use hash map and tree map respectively. We have the size of the map. We have putting a key value pair. We have getting a key, which is getting the value associated with the key, which is just .get, and then .contains key. So all of these are very similar to the methods in set, which makes sense because there's two types of maps and two types of sets. You'll notice that practically all of these except for array had the same format where I just needed to specify the data type, the name, and then what type of data structure I'm trying to use. For maps, it's the only one you have to be a bit more careful about because maps take in two things, or maps have two data types that you need to consider. So let's say I'm trying to do a name to age. So I'd be mapping a name to the age, which is an integer. So I would need to add an extra data type right there. That's the only thing you have to worry about, or I mean to be careful about. So if there's no questions left, I think it is time for Tina to do AMC 10. I'll make her host. Okay, thanks everyone. Have a good day.
Thanks, Andy.
Bye.
All right, I'll give you guys